Hello and welcome to the very first video in a non-traditional regression. For the first time, we're going to be seeing the non-linear regression. We have seen simple linear regression. We have seen multiple linear regression. Today, we're going to be talking about non-linear regression. I obtained this set of data from a website, and it was very helpful. If you decided to know what's the website, here it is. You could take your time, of course, and look at it. It's called www.excelmasterseries.com. Very helpful for future references and how to use Excel for your econometrics problems in the future, or any sort of regression and business, basically. So if you like it, go ahead and read the article fully if you want. And I just wanted to give you a warning that I'm using my approach in different style to how I'm going to do the interpretation for the graph than what they did. All right, so let's go ahead and look at this one here. This is basically the set of data that I'm going to be looking at. And if I do the chart, and we want to see if it's just going to give us a linear regression looking chart, or it's going to be non-linear. So I go to insert, and as usual, we do go to the scattered, and I'm going to go ahead and click on it. Immediately I could sense there is no really straight line, because it's kind of like the values of y's is going to be a little bit diminishing where the value of x is increasing. Or if I don't want to say anything at all, I wanted to really make it much better looking than what I had in order to really conclude this is not linear. And you have to use your intuition, believe it or not, to start with this process. There are those moments that you have to really use the best possible deduction reasoning about it. So let's first of all get to see what is the minimum value for the sale. That's the minimum value. And I'm going to also find the minimum value for the number of the ads running. So as you notice, y is the number of the ads running. That's going to be the dependent variable. And x is going to be the number of the sales. Obviously, it's going to be either in millions or thousands, something other than these figures, in order for them to run that much numbers of ads. When I get the minimum 50 and the minimum 6,700, I will be able to easily change the axis. If I click on the right button, the format axis, since it's giving to me by Excel as a zero value, I'd rather have it for the y-axis to start with, let's say 6,500. That would be great, and see, notice it start to look really clearly because we kind of like magnified it or zoom it in. They will be able to see that the curve is start to show. And also, since we have the minimum here is 50, so if I click on the right button for this one here to format the x-axis, let's go ahead and put the minimum like 45, okay? And we could make the largest value 190, okay, since we have only 180 here. And that's really looks good. The major, we could change it from 20 to 10, so we could see it even better. And notice it clearly that this actually becoming very non-linear. But if we know now it's non-linear, there is many types of non-linear curve. Which one of those we're going to actually decide to use, because some of them really could be very confusing. So I'm going to use Excel. It's not a cheat. That's what we're using in this class, Excel, all the time, instead of trying to refer back to your algebra books and maybe other software that we have all over the internet. I've been using them all this morning to see what would be the best fit. And luckily that I found Excel is the best approach for the whole thing, because it's right in front of us. We don't have really to guess too much. So we're going to look at this chart and also see how we're going to be actually comparing what we see versus what are the options provided to us by Excel. So I'm going to go and click the chart, go to the design, And notice I could go to the add elements. Okay, if you have 2010 or 2007 Excel, you're going to have a different option associated with the chart tool. So as long as you could get to the axis and also the trend line, you'll be able to be in good shape. I'm not going to choose linear. I could, but obviously it's not linear. You could see how, you know, the dots are not really close to a linear shape. It could be exponential, it could be a linear forecast, could be moving, it could be something else. Let's go ahead and take a look at more trend line options. And now if you don't see this, because it's really coming directly to the line and fixing it or making it different colors or whatever you want, this is not what I'm interested in. Now I'm interested in getting into that trend line option, which is this one here, if using 2013. If you don't use 2013, then you will have no problem seeing it right there. And now look, we have exponential. Obviously this is not an exponential because exponential is, let me go ahead and do that on the side here. So I could go ahead and use the review, and I could use some of that ink here, and I'll be able to click on that first of all. Actually, I don't have the ability of doing it both with this and that, so I'll be able to view it. What I could do, you know, if to stop this, and let me click on that one here and go to this one here. If I click on it, thread line, okay, I'll go ahead and use my Snagit, which is a software that allows me to grab an image or part of an image and put it as a picture next to my view here. So, okay, actually I could activate it with a print screen. Hopefully it's coming. All right, so maybe it's taking longer than what it should. All right. Somehow it's not being activated. Okay, I'm not going to worry about it, but let's go ahead and get to this one here. Obviously, if you look at the curve here, hopefully it will leave it alone. Nope, it's not going to leave it alone. So, you know, when I click on this, anyway, our curve looks like this. Let me go ahead and put it this way. Our curve looks like this. Okay, so this is how our curve look like. Okay, so it's not a line of any sort. So keep that in mind. I'm going to go ahead and use the best possible tool available for me. And now, if I go back to this one here, okay, close that, okay, going to click on that to close it. And I'm going to click on the thread to go ahead and get it back. Sorry, I'm confusing you probably. And now, what is the closest one to, this is not exponential. Oh God, sorry. This is not exponential. The shape or the red shape, this is not linear. Could be very much logarithmic, and definitely it's not polynomial. It's not power. It's not moving average. The closest shape to it is logarithmic. So this is basically what it is. And now you see the curve. You know, this is my actual data, and this is my predicted curve. They're really close to each other. So this is good in good shape. And I'm going to go ahead and say display equation on chart and display R square on chart. And that's exactly what I want. I'm going to delete this, and I'm going to delete the red one, take it out of your way, so I could focus on what I have here. Look here. If I have here, see here, I have it really nice because now I have the tab of the equation that I don't have to guess what it is, you know. And I have, this is actually what we considered earlier, the intercept. And this is going to be, you know, that's what the value is multiplied by the logarithm. So what we need to do first of all is the R2, is going to indicate the type of the correlation between the two variable sales and number of ads running. Perfect. There is a deep, very good type of correlation. I'm going to take this one here and press Control C, and I'm going to go ahead and put it here and run you through what we need to do in order to get the best possible outcome for this solution. And we're going to be using Solver in Excel. But before we get to Excel, I'm going to be using, first of all, to see, I'm going to call this value, I'm going to call it A1, and this is A2. Okay, so what we're going to do here, first of all, it's going to be, okay, let me go ahead and put that exponents, yeah, minus 8757.9. Nope, I did actually, I'll change that 8, this is to 8. Okay, and this is going to be 4153.2. All right. My ultimate gain, this is you never seen before, so we're going to talk about how to use Excel in order to predict the possible outcome for us. We do have already our prediction equation. So this is the predicted value. Okay. This is the predicted. Okay. This is our predicted value. Okay. The other one is the actual value. That's basically. And how are we going to do this? We're going to do this basically by taking this, multiply by ln, the logarithmic or logarithm of the x, which is in this case here, minus, which is already minus, so let's go ahead and say plus this. There we go. So this is my predicted value. But I need to go ahead and lock this by hitting F4, and of course lock this by, not locking this, this is going to be changed, locking this by hitting F4 as well. So here we go. So we could go ahead and click the twice in order to get the predicted value. So this is the predicted value. Let's go ahead and find the difference. Okay, the difference is to take this, subtract it from this. Okay, and we're going to go ahead and click as well. Okay, I need to get the square of the difference, and I'll explain to you what I'm doing here of difference. And I'm going to go ahead and say it is going to be this, and that's raised to the power of 2. And I'm going to go ahead and click all that. Then I'm going to find the sum of the square of difference. Okay, here we go. And it's going to be sum equals sum, and open parentheses, and go ahead and hit enter. I have to close it. So this is basically the sum of all the square. How are we going to, I'm going to always color it green. And for this case here, if I change this one here to, let's say, instead of using the model, I know what type of model, this is the best possible. Keep that in value for me. I'm going to go ahead and copy this and put it right there here. Okay, paste it here. Basically, I'm going to, and I'm going to go ahead and put right here. Of course, I need to copy that value. Copy. paste this special, and I'm going to only copy the value because I don't want it to. Okay, and we could go ahead and make it a little bit larger, so let's see what we got, because I want to keep that track of this. Okay, so what we have to do in order to get the best possible value for this model is to minimize this value. If there's any way we could minimize the sum of the square of differences, that would be the optimal solution. Okay, so what we're going to do, we're going to be able to go ahead and we could use any values for A's and B's, I mean A1 and A2, and this is what we use from the model in order to predict those. But let's go ahead and see also what would be the best possible value for A1, which is this one here, the intercept, and this actually the coefficient of the logarithm here. So let's go ahead and assume that I put here 100 minus 100. Okay, and here's 100. Of course, it's going to change that. You know, it changed it. It made it very huge number because these are small numbers. This is the original number that we got to start with. Okay, and we wanted to go ahead and see how the model is going to be solving this problem for us by finding different values to these, the intercept and also the coefficient of the logarithm. So I'm going to go ahead and make this actually yellow, okay? Just to make sure that to tell solver, these are the one that you need to change for me in order to minimize this. So this is need to be minimized by changing these two values, okay? If I put this 100, of course, for now it doesn't matter basically. I want it to minimize it very small, even smaller than this value, okay, to start with, because that's the value that I got if I use the plain equation that is provided to me by Excel. So what I'm going to do, I'm going to go ahead and for the first time you're going to see solver. We're going to use solver heavily toward the end of the class, but for now we're not going to even have nothing but the simplest form of it. So now what is going on here, this is my objective equation, or the set objective equation that I have done all the addition of the square differences, and my ultimate aim is to minimize it. Okay, what do I minimize it by? By changing these two values here. See here? Because those are the two values that I actually changed my mind about, or I even could use the initial one, minus 8757.9 4153. I just want you to see that I could change it because Excel solver is going to really find the best possible outcome for me. So let's go ahead and see. By changing this, there's no constraints whatsoever here. So that's the easiest form of using solver. Of course, don't check this here, because if you check this, it's going to put it's going to take the -1 and make it 0 at least. So because we do have negative values, and of course, if your simplex, which is the default one, please change it to GRG nonlinear. This is the nonlinear model, and I click on solve. Before I do actually click on solve, I wanted to go ahead and change two things. I'm going to click on this one here, and I change the name of that one to, let's say this is the intercept. Here, that's the naming of the area. And this is, I'm going to call it, or I could call that A1. It's better. Here we go. And I'm going to call this A2. So this is going to be looking like this. The formula is going, the equation is going to be y a2 ln x plus a1. Okay, so this is in the translation of it. So let's go back to the solver, and I have already the objective function is already set there, or equation, by changing those two here. Okay, and also I named them A1 and A2 in Excel because I wanted to have a good report, and change the simplex LP to GRG nonlinear, select the solving methods, and I'm going to go ahead and solve it. Remember, it has to be set to minimum because the ultimate goal is to minimize the square of the differences to find the best possible solution for that model. So we're going to go ahead and solve. After we did choose minimize. Later we're going to be using maximize. We're going to be using set of value at certain value. Of course, here we're not really maximizing the profit here. We are minimizing the square of differences for this model in order for us to get the best possible solution. So let's go ahead and say solve. And now we immediately got the best, let's see here, and I'm going to accept this. Notice that solver found the minimum value possible is actually similar to what Excel did in the Trendline, which is amazing to me because actually it's a little bit tinier, which is like a fraction. It's 0.52. This is 0.944. A little bit better, but that's insignificant better. Of course, we could run that again one more time to see solver if it's going to give us anything different. And I could say here, okay, not that significant at all. But this is basically get Excel with the trend line gets the best possible solution. I could minimize it a tiny little bit by going through the solver. Solver is your ultimate goal to do it, and we need to be able to do that in solver. Of course, if I give you a problem like this, I'll be able to explain to you after you do this whether you need to maximize it or minimize it. In this case, we wanted to be able to minimize the number of the ads running in order to increase the sales. And notice, the intercept is a negative value here, and because one goes up and one is going, diminishing, like the Y value is diminishing when X goes very large. So we want to really minimize the number of the ads running in order to still get a bigger sale. So what are we going to do with this? We're happy with it. We're happy with it. So we're going to go ahead and say what would be the 190 if I did sale 190. Obviously the predicted value would be 13034 for that number. And now we are in good shape because the only thing I have to do here is to change this to this one here. I guess this one here and this one here is going to be changed. I'm going to make it just a slightly different. I still call it intercept. It took the first one instead of calling it A. And here, this should have been called A1. Okay, it's no big deal. We could go ahead and leave it as it is, but that is actually the predicted value when we use 190 if we do not observe or do the observation here as we did before. I know it's a long video, but this is the only video for these 2 days, and I hope you enjoy it, and we'll continue to do other videos for you in the future. Thank you very much. This is Dr. Sam Hijazi. I hope you have a wonderful day.